This is the Lewis dot diagrams in forming ions worksheet. So Lewis dot diagrams show an element with the appropriate number of valence electrons, the outer electrons, or the last number in the electron configuration. Write the symbol of each element and place as many dots as there are valence electrons around the element symbol. There should never be, that's very important, there should never be any more than 8 dots because there are never more than 8 valence electrons. Remember, the first ring can hold 2 electrons, the second ring can hold 8 electrons, and the third ring we're only going to go up to also 8 electrons. So we never have more than 8 dots for the Lewis dot diagrams because we only worry about the electrons in the outermost energy level, the valence electrons. Okay, so for this you just have to fill in the elements and then draw the valence electrons. So they did some for you. They did hydrogen and helium, carbon, and sulfur. And what I've gone ahead and done is filled in the elements, but I haven't done the dots yet. So if you need to pause so you can fill in the elements, go ahead and do that now. Okay, so we're gonna go ahead and fill in our dots. So the easy thing to look at to figure out how many valence electrons you need and how many dots you're going to need is to look at the group number. So group number 1 has 1 valence electron. So all of these are going to have 1 dot. And again, it doesn't matter from the notes. It doesn't matter if you start at the top or the side. When there's only 1 dot, I, for some reason, do it on the side, but you could absolutely have that on the top just as easily. It really doesn't matter. When there's only 1 dot, you can put it wherever you want. Group 2 has 2 valence electrons, or 2 dots. Okay, so put your 2 dots on there. And remember, we don't put dots next to each other until we have 1 dot on each side. If you look at carbon, you can see there's 1 dot on each side. If you were to imagine that carbon is inside a box, so we have 1 dot on one side and 1 dot on the other side. Okay. Group 13 has 3 dots. Remember, we won't have more than 8, so you can't have 13 dots. So you have 3 dots. Okay, so 1, 2, 3. 1, 2, 3. Okay. Group 14 has 4 dots, and you can look at carbon as an example to figure out how to do silicon. Silicon's also going to have 4 dots. Okay. And remember that all the elements in a group, groups go up and down. So this is group 1, this is group 2, group 13, group 14. All the elements in a group are going to have the same number of valence electrons. Group number and valence electrons are related. So group 15 has 5 dots. So again, you're going to start, and this is where you have to be careful. I typically start on the top for these. There's 4, and then the 5th one is going to go on top with the other one. But you could do it like this. You could do it like this too, and it would be totally okay. You could start on the side, and that would be fine. As long as you have 2 dots on one side that are together, and then 3 dots are lonely, or they don't have a partner on their own sides. Okay? It doesn't really matter where you have the electrons that are paired up. I typically draw them on top though. Just a personal preference. So you can choose your preference and just keep doing them that way. So phosphorus is going to have the same configuration. It's going to have 5 dots. So 1, 2, 3, 4, 5. I don't know why sometimes it does that. There we go. Okay, group 16 has 6 valence electrons, so 6 dots. 1, 2, 3, 4, 5, 6. Sulfur was already drawn for you, and you can see that oxygen matches sulfur. Fluorine and chlorine are in group 17, the halogens. They have 7 dots. They're 1 away from that noble gas configuration. So 1, 2, 3, 4, 5, 6, 7. So with 7 dots, you're only going to have 1 electron that doesn't have a friend, 1 lonely. So here's our lonely electron there. All the other guys are paired up. Remember, if we were to imagine that the symbol is in a box, you can see that there are 4 sides. Chlorine should look the same. 1, 2, 3, 4, 5, 6, 7. Okay, and then neon and argon are in group 18, the noble gases. And remember that helium is different from the noble gases because it only has 2 electrons in its outer shell. It only has 2 electrons total. So the first shell is the outer shell. And that first shell can only have 2. But neon and argon both have more energy levels than that. And the second energy level that neon has can have up to 8 electrons. And argon has 3 energy levels, and that also has 8 electrons. So neon and argon both have 8 valence electrons. So they're going to be full. They're going to have 2 on each side. So we can do the same thing for argon. And because we know it's going to be full, I went ahead and drew it like that, just because we already know that it has 8 electrons, so it's going to be full. So it doesn't really matter on that one. Keep in mind, atoms start out neutral because they have equal number of protons and electrons. Okay, protons are positive. Oops, let me make that a little skinnier there. Protons are positive, electrons are negative. So if those are the same, they're going to cancel out. However, they want to be stable and have a full outer energy level. Losing or gaining electrons results in an ion, or a positively or negatively charged atom. Everyone wants 8 electrons to be full and stable like the noble gases. Positively charged ions are cation ions, so cation ions are positive. And negatively charged ions are anions, so those are negative. Remember, cations, cats have paws, they're positive, cations. And anion, the word anion kind of looks like an onion, the word onion, so and onions make you cry when you chop them, so that's negative. Atoms will fill their outer shells or empty them. They will do whatever requires the least amount of energy. Example, it is easier to lose 1 electron compared to gaining 7. So let's look at these questions here and see what we mean by that. So elements in group 1. So we're looking at these elements here. Okay. Actually, we're not going to focus on hydrogen. We're going to look at lithium and sodium mostly. Just because hydrogen is in that first energy level, which only has 2 electrons, so we're not going to worry about hydrogen. We're going to look at lithium and sodium. So elements in group 1 have how many dots? They have 1 dot on their Lewis dot diagram because they have 1 valence electron. So would it be easier for these elements to lose that electron, because they're either going to empty their outer shell or they're going to fill it, and they're going to do whichever one is easier. So they can either lose 1 or gain 7. Okay, so what is easier? What's the smaller number, 1 or 7? So 1 is smaller, so that's what we're going to do. So we're going to lose 1 electron. Okay, group 2, that's beryllium and magnesium. They have 2 dots because they have 2 valence electrons. So go ahead and fill those in. So they can either lose those 2 electrons or gain 6 electrons. And I didn't really explain this on that last one, but why gaining 7? Why gaining 6? Where are we getting that number? Well, remember, the second energy level and the third energy level can have up to 8 electrons. So we can either lose all of our electrons that we have, or we can gain enough electrons to fill the shell, which is to get to 8. So the reason that this is 7 is because 7 and 1 make 8. So that's where that number came from. So we can either lose all the electrons we have, which is 2, or if we gain 6 more, that gets us to 8. Okay, so which one are we going to do? Well, 2 is smaller, so we're going to lose 2 and not gain 6. Okay, so we're not going to do this, and we're not going to do that. Elements in group 13, so that's boron and aluminum, they have 3 dots. on their Lewis dot diagram because they have 3 valence electrons. So they can either lose all 3 of their electrons, or how many do we need to get to 8? Well, we need 5 to get to 8. So we can either lose 3 or gain 5. Those are the 2 options. You either have to lose them all, so you can go down to the next energy level, which will be full because it's inside, or you have to fill the current outer shell. So those are the only 2 options. So the smaller number, the least amount of energy, would be losing 3 electrons. So that's what it's going to do. Group 14, that's carbon and silicon. They have 4 dots because they have 4 valence electrons. Would it be easier for group 14 elements to lose 4 electrons or gain 4 electrons? This is a trick question. They don't actually form ions, so they do neither of those things. You can just cross them both out. These elements rarely form ions because they're in the middle. Losing 4 and gaining 4 requires the same amount of energy. They don't give up or gain electrons. They actually share electrons. That's called covalent bonding, and right now we're looking at ionic bonding. So they do something different. Elements in group 15, that's going to be nitrogen and phosphorus. You can see how many dots they have. They have 5 dots because they have 5 valence electrons. So again, we can either lose all of our electrons, which now we have 5. We're getting up there. We're getting to the point where now we have more electrons to lose compared to how many electrons we could gain to get to 8. So if we have 5, that means we only need 3 more to get to 8. Okay, so that's what we're going to do. We're going to gain 3 electrons to get to 8. We're not going to lose any. Okay, group 16, that's oxygen and sulfur. You can count that. They have 6 dots. So that means they have 6 valence electrons. We can either lose all 6 of them, or to get to 8, we only need 2 more. So that's what we're going to do. We're going to gain 2 more electrons to get to 8. And elements in group 17. So let's scroll up and look here. That's fluorine and chlorine. They have 7 dots because they have 7 valence electrons. So fill those in. So they can either lose all 7 of their dots, or how many more do they need to fill it? They need 1 more to get to 8. And so 1 is less than 7, so we're not going to do that. We're going to gain an electron. So notice that the first 3 groups that we have, 1, 2, and 13, they lose electrons. Okay, and then our last 3 groups, except for the noble gases, groups 15, 16, and 17, they gain electrons. We skip group 14 because it doesn't do either. It's in the middle. And if we look at group 18, most of them have 8, except for helium, because they have 8 valence electrons. The only exception is to having 8 dots is helium because it only has 2, remember. Group 18 elements do not form ions. Important there. Do not form ions because their outer energy levels are already full. So which groups tend to give up electrons? So these are the ones that are losing electrons that we just said. So if we scroll up and look, the ones that are losing are group 1, group 2, and group 13. So 1, 2, and 13 are what I'm looking for there. So 1, 2, and 13. Look at lithium. So a neutral atom of lithium has 3 protons because the atomic number is 3 and 3 electrons. So we've drawn 3 protons and 3 electrons. Okay, 3 protons, 3 electrons. The protons, remember, these would be in the nucleus, and the electrons, these would be in the electron cloud, or the energy levels. Okay, but that's why the atom is neutral, because the positives will cancel out with the negatives. Okay, lithium is in group 1. Earlier, you should have said that group 1 elements will lose 1 electron. So let's go ahead and do that. Let's get rid of 1 electron. Okay, if I color over that with the white, we can really, truly get rid of it. Okay. Let's do that. Let's truly get rid of it. All right. Let's go back there. Okay, so now you can see what happens. So now I've got 3 positives. I've got 3 positives, and I've only got 2 negatives. So this will cancel out, and this will cancel out, and that'll leave me with a positive left over. So now lithium has more protons than electrons, making the overall charge positive. The overall charge would be positive, not negative. Remember that atoms start out as neutral with the same number of protons and electrons. If they lose electrons, there would be more or fewer electrons than protons. Well, if you can see here, we only have 2 electrons and we've got 3 protons. So if we lose electrons, that means there's going to be fewer electrons, not more. Okay? Making the overall charge positive. We just said we have, so this one cancels out with this one. This one cancels out with this one, so we have an overall charge of positive, not negative. So losing electrons makes us positive. And remember that positive ions, positive, are cations. Oops. Sorry, cations. I forgot which thing I was on there. Not anions. Cations are positive. So that's what happens for groups 1, 2, and 13. They're going to lose electrons. They lose different amounts. So group 1 loses 1, group 2 loses 2, and group 13 loses 3 electrons. So they're going to have different charges, but they're all going to be positively charged. So losing electrons makes you positive. Which group tends to gain electrons? So if we scroll up and look at page 1 again, losing electrons was groups 15, 16, and 17. Oh my gosh, I just read that wrong again. Tend to gain. We're gaining now. Forgive me. Gaining electrons. Okay? Gaining electrons is group 15, 16, and 17. Gaining electrons. Okay? The more electrons you have, the easier it is that's going to be to get a few more instead of losing all of the ones that you have. So groups 15, 16, and 17. So looking at nitrogen, nitrogen has an atomic number of 7. 7. So it has 7 protons and 7 electrons. So counting here, 1, 2, 3, 4, 5, 6, 7. And the electrons, 1, 2, 3, 4, 5, 6, 7. 7 electrons. So we have 7 protons in the nucleus and 7 electrons in the energy levels. So earlier we should have stated that if you're in group 15, you want to gain 3 electrons. Okay, so let's look at that real quick here. So group 15 wants to gain 3 electrons. Remember, they can either lose all 5, or to get to 8, they only need 3 more. So they're going to gain 3 electrons. So we've added 3 more electrons. These are additional electrons added on. So let's do our canceling here. This proton cancels with this electron. This one cancels with this one. Canceling here. This positive cancels with this negative. Canceling. Proton cancels electron. Proton cancels electron. We're out of protons, and so you can see now that we've got 3 extra electrons. 3 extra electrons. So my overall charge is then going to be negative because the extra electrons are negative. So we're going to highlight negative. Okay. Remember that atoms start out as neutral with the same number of protons and electrons. If they gain electrons, okay, if we're getting more electrons, that means we're going to have more electrons than protons, not fewer. And the overall charge is going to be negative. Negative. because electrons are negative. If you're getting more electrons, you're going to get more negative. And remember that negative ions are anions. Okay, it's not the cation. Anion looks like the word onion, and onions make you cry when you chop them. So that's negative. Looking at a few examples. So let's draw the Lewis dot diagram for fluorine. We can go back to the first page and look at how we did that one. So scrolling up, here's fluorine. It's in group 17, so it had 7 dots. Okay, so let's go ahead and draw that down below. Okay, fluorine, and draw your 7 dots. All right. I'm going to move that up just a hair so that all the dots are above the line there. All right, good stuff. Would fluorine lose all 7 of its valence electrons or gain 1 more electron to get to 8? So earlier we said, remember, group 17 gains 1. Does not lose electrons. Remember, you want to pick the one that's a smaller number. 1 is less than 7, so we go with 1. We're going to gain an electron. What would be the charge? So if we lost 7 electrons, we'd become positive however many electrons we lost. So we would be plus 7, or if we gain 1 electron, we're going to be negative 1 because we're gaining 1 electron. Gaining means negative, and 1 electron means the charge would be negative 1. So because we're gaining 1 electron, our charge is going to be negative 1, not plus 7. And then write the ion symbol with the element symbol and the charge in the upper right. So that's going to look like this. And I did that one for you so you could see. Since we haven't drawn that symbol before, I wanted to go ahead and give you an example of what that should look like. Magnesium. Again, you can scroll up to the first page if you need to, but magnesium is in group 2. So it's going to have 2 dots. So 1, 2. So magnesium can either empty the shell and lose the 2 electrons it has, or it can fill the shell, and to get to 8 we would need 6 more electrons. Okay, so which number is smaller? Which one would require less energy? 2 electrons or 6 electrons? Okay, well, 6 electrons is not the answer. So we want to lose 2 electrons. That's smaller, less energy. And what would be the new charge? So losing electrons is positive, and if we lose 2 electrons, it would be plus 2. Or if we gained 6 electrons, it would be negative 6. So we decided that we were going to lose electrons, so that means the charge is plus 2, not minus 6. And then write the ion symbol with the element symbol and the charge in the upper right. Well, the symbol for magnesium is Mg. And we said the charge is going to be plus 2, so that's going to go in the upper right, just like this one. So we're going to put plus 2. And I will let you know, sometimes you'll see it written as 2 plus. Both ways are correct. I would accept both ways. I will draw it different ways sometimes, but they mean the same thing. Sometimes the positive comes before the 2 or after the 2. Both ways are accepted and completely right for our purposes for Science 9. Okay? So same thing with the fluorine. You might see it say 1 minus, or sometimes because it's a 1, it's just assumed, so sometimes it'll just say minus. So if you ever see a minus or a plus without a number, then that is a 1. Okay? But all 3 of these would be correct, would be acceptable ways to write that. The charge. Okay? So now list the charges for groups 1, 2, 13, 15, 16, and 17. So notice we've skipped group 14 and we skipped group 18. So group 1. So group 1 we said will lose its electron. It only has 1 electron. And it's going to have a charge of plus 1. I gave that to you. Group 2, and you can scroll up to look at this information if you'd like. Group 2 has 2 electrons, and it's going to lose them. Okay? If it loses electrons, it's going to be positive, and it's going to be however many electrons it lost, it's going to be 2, so plus 2. Group 13 has 3 electrons, so it's going to lose 3 electrons. If we're losing electrons, we're positive. Okay, and because we're losing 3, we're going to be positive 3. Okay, group 15 has 5 electrons. At this point, it's going to be easier to gain electrons to get to 8. So it's going to gain electrons. It has 5, so it needs 3 more. We're going to gain 3 electrons, and the charge is going to be negative 3 because we're gaining 3 electrons. So gaining electrons makes you negative, and it's gaining 3, so it'll be negative 3. Group 16 has 6 electrons, so it can either lose 6, or to get to 8, it only needs 2 more, so we are going to gain 2 electrons. And gaining makes us negative because electrons are negative, and we're going to be negative 2 because we're adding 2 electrons. Group 17 has 7 electrons. We can either lose 7 or gain 1 to get to 8. So we are going to gain our 1 electron. Gaining is negative. Okay, so negative 1 because we're gaining 1 electron. Now what you're going to do is you're going to take these charges and you're going to put them on your periodic table that you have for tests and quizzes that you have in your sheet protector at home or in your book bag, hopefully, that you should be bringing to school every day you're at school. You're going to label these 6 groups that we have, and you're going to put the charges that we just wrote down above those group numbers, just like this. So on your periodic table, you should have the periods labeled. You should have the group numbers labeled. Okay. You should also have valence electrons labeled. I have mine circled so I know the difference between the valence electrons and the group number. And then I also have a little star for helium here. And then now you're going to add this. You're going to add the charge, and I wrote mine in a different color. You're going to add the charge above just the 6 groups that we mentioned above. Okay, just those 6 groups. All right. Also, guys, don't forget that you should have your periodic table labeled. So you need to know what these colors mean on your periodic table. And that should be on the back. So the black ones, these are the transition metals. The pink ones down here, these are your rare earth metals. These yellow ones, these are the other metals. You should have that information on the back of your periodic table. Otherwise, these colors are meaningless. You don't know what they mean. Okay? So make sure you have that labeled on your periodic